Oh, uh, like Christopher said, this is the AO8 final review final review seminar. And so yeah, let's just get started. So yeah, we'll be going over basically everything from the term test all the way to the final exam, which includes like tuples, dictionaries, files, unit testing, sorting algorithms like insertion and selection sort, and obviously also runtime. So, starting with tuples, we know that tuples are basic, or an n tuple is basically an ordered grouping of any n elements, right? It's really similar to a list. It's similar to a list in terms of that it is just a collection of items, right? However, where it is different from a list is that it's immutable. This means that once you've created a tuple, you can't really modify it or like remove elements or add any other elements to it, right? However, however, we know that inside of a tuple, we could have elements such as a list, which are mutable themselves. So that means inside of a tuple, you could have a list which you could change, but it won't be changing the tuple itself. And because we know that tuples and lists are very similar, we know that we have like these functions of the function list, which takes in an n tuple and it'll return a list with all of the elements that were in the original tuple, but in list format. And similarly, going the other way, we know that if we have some list, calling the function tuple will return a tuple of all the elements which were in the list, but now in a tuple format. So you can see that there are a lot of similarities. Tuples and lists, they kind of go hand in hand. However, just tuples are basically immutable. You can't really change the elements within them. So how would you go about accessing a tuple? It's again, since it is very similar to a list, we know that it starts with index 0 and goes up to index n minus 1 if the length of the tuple is equal to n. So that means that as it states here, that ti will return the element at index I of the tuple t. It's the same logic as it is for list, so that makes it a lot easier for us. And similarly with slicing, we know that for list, if you were to slice, it would return a sub list, or it would return a new list, which is basically a sub list of the original list. Similarly with tuples, if we slice it, we'll just get a new tuple back, which has elements from the original tuple. And its start and end index, as it says here, is that it includes the starting index, but it does not include the ending index. So moving on to dictionaries. So what is a dictionary? A dictionary in Python is just a collection of key value pairs. So in real life, you'll probably see something a lot more like this. This is human readable. You can understand it. You know that the key of A is associated with the value of 1. Similarly, B is associated with 10, C is associated with 100, and so on. But then how would that look in Python? It would look something like this, where we have this dictionary, which we know it's a dictionary because of these curly braces, as well as we can see that the character A is associated with the value of 1, B is associated with 10, C is associated with 100, and so on. So these two things, where the left side is what we would see in real world, or if we were to write it down, this is on the right side is how we would interpret it in Python, or how we would write it in Python. And we can see that if we wanted to print out a certain value, let's say in this case, we wanted the value associated with the key C, all we would have to do is just give the key or give the key itself, which is the character C. And we would get the output of 100, which is the value that's associated with C. So moving on, we know that dictionaries are unordered collections of key value pairs. That means there is no really sorting to them. There is no first or last element in a dictionary. It's just a bunch of key value pairs, and we can just pick and choose the ones we want. We know that the values can be of really any type. The values themselves can be anything. Like it says in another dictionary, there is no limitation on what the values could be. However, there is a limitation on what the keys could be. We need the keys to be immutable data types. This means that we can't have like a list or another dictionary be a key because we those are mutable and we specify or Python requires the keys to be immutable. So here are just some examples. We can see that valid keys would include data types like integers or floating point numbers or strings, while invalid keys would be, as I said, like dictionaries or lists because those are immutable. So going on, there's two ways to basically declare a dictionary. I know there are three on the screen. However, there are two ways. Mainly the first two, because I'll get into it, but the second and the third approach are the exact same. But going into the first one, basically we can create an empty dictionary and then start manually assigning key value pairs. We can assign the key of 0 with the value of A, 1 with B, and 2 with C. And this is all into an empty dictionary. Or just right off the rip, we can just basically assign when we're creating the dictionary, instead of creating an empty dictionary, we can just put the key value pairs inside of the dictionary. This saves us a couple of lines, so we don't have to do manual assignments, and we can just do it off rip. And what I meant by the second and third options are the exact same, is that because we know there is no sorting to these or there is no ranking to them, we know that the second and third are the same, even though it's just we've put them in different orders. Like we have 0, 1, 2 here, while on the third picture we have 1, 2, 0. Moving on, we know that there are a couple of functions that we have with dictionaries. So the first function that we know is that there's an in operator. You can see this dictionary has apple, banana, and grape. And what this in operator does is it checks if the key is in the dictionary. So we check if apple is in this dictionary, and we'll get an output of true. If we check if pair is there, or if pair is a key, you'll see there's no pair, so we get false. We have the len function, which is similar to lists, where it just gives you back the number of key value pairs. Here you can count three. So if you call len, you'll get an output of three. And you also have a dot items method, which basically returns like collections of tuples which have key value pairs. So you'll get two tuples or it'll be a collection of two tuples where you'll have a key and its associated value. So here you can see we have again three key value pairs. And if we were to just loop through the dictionary dot items, we'll get back these three outputs. So yeah, this is one way to basically shorten up your code. So a lot of students and a lot of people in general, they do the bottom where you can see they loop through the dot items and manually assign the first and second element. So they manually assign the key to some variable and the value to some other variable. Although this is very short and it's very human readable, the top just saves you some time because Python manually does those assignments for you. You can just in your for loop declaration, you can have the variable that you want to contain all the keys and comma the variable that you want to contain all the values and run it through dot items and it'll do the bottom assignments all in one line. Just moving on to some more functions. We know that we have the dot values method here. Yeah, so we have the dot values method, and this basically returns a collection of all the values within the dictionary. So basically it just does what it says, right? So we have these values of 4.5, 3.5, and 2.5. If we were to call dot values on the dictionary and run through a for loop, you'll see we'll get each value one by one. Similarly, with the dot keys function, it'll do the exact same logic, but with the keys instead of the values. Then we have the assignment operator, which means that we can just basically add in new key value pairs anytime we want. So in this case, we have apple, banana, and grape. And if we try to call pair, you'll see that we don't have pair as a key within this dictionary. So what can we do to basically change that? We can assign pair to the value of 4.5 with this line right here. And if, let's say, pair was already a key within the dictionary, this line would go and update the value of that's associated with pair. So this assignment operator either creates a new key value pair or it updates the value of the existing key. And as you can see, if we were to just print it out at the bottom, we'll get the value of 4.5. So these two concepts aside, we get to our first practice problem of this seminar. And this question basically tells us to complete the body of the function. We're given this docstring, so I'll read it out. We have to return the dictionary, mapping each item name to a tuple, which is of the price and the rating, according to the list, menu list. Menu list being our parameter name. So if the rating is greater than 5, then we map it to price, comma, -1. Okay? And so the precondition that we are allowed to assume is that each element in the list has the format item name, price, and rating. So let me break it down before you guys get started. We have menu 1, which is this list on the left. We can see it follows the format item name, price, and rating. And once we pass, this would be an argument, or this would be a valid argument into the function, and the function should output something similar to the bottom right here, this bottom variable. Now, so I'll give you just a couple minutes to do that, about like 5 minutes, and then I'll go on to the solution. All right. It's been about like 5 minutes, 6 minutes. Do you guys need more time to solve the question? If you do, just like let me know in chat. Uh, yeah, so I'll just wait a couple of seconds. So yeah, let me know if you guys need more time. Yeah, sure. I'll give just like a couple more minutes, like 2 to 3 more minutes, and then I'll go on to explain the solution. The last sentence, it talks about it's saying that if the rating was greater than five, then we should map the va or the key to a tuple of price, comma, -1. So price being the actual price itself, and then we would give it a rating of -1. Uh, so that's because like we're assigning string or what we want to do is basically, as you can see, the final output is have a string and its associated value is a tuple of two integers. And if the rating is greater than five, then you see where hamburger has a rating of five. Let's say if the rating was six originally, we would just put -1 as the rating instead. That's all the final sentence says. All right, so I'll start going into or going over the solution. So, this is like a common solution that some people have come up with. So I'll go through it. Basically, this is just another example for the doc string where we just have menu two being hamburger, comma 10, comma 5, and it should return this. And if we were to check the equal, that the output of the function gives us this output, we get that as true. So that example is valid. And now let's go through the logic of the code. We can see that we first initialize an empty dictionary and we run through the parameter that we're given, or so the list of strings. And so we split by commas, which means that, or it gives us a list of strings after we split, and we just take the first element, the second element, and the third element, which correspond to the item's name, price, and rating. So, uh, that's like this is all valid so far. And what we then do is we create a tuple with the item price and the item rating, and then we go ahead and check if the item rating is greater than five. If it is, then we go into the tuple and assign the second slot of the tuple to -1. And this does seem valid. And then once we do, then we just basically assign it to the dictionary with the item name as the key and the tuple that we've created as the value. This does seem valid at first. However, when we do break it down, we see that there are a couple of mistakes in our logic. So what we do first see is that, or like this is a convention, but we want to have meaningful variable names. The variable name D or like dict or A, they're not really meaningful. They don't really tell us what the variable is about. They don't give us much info if someone else, they wouldn't give much info if someone else was to read our code. So that's just a convention. But then going on to like logical mistakes, you can see that Uh, this line right here, this if statement is not possible or it's not allowed in Python because as I did state that tuples are immutable. Once you create a tuple, you can't modify a tuple. So once we do create the tuple of item price and item rating, once we do create the type tuple of item price and item rating, we can't just go ahead and change the value of item rating inside of the tuple. That's just not allowed within Python. And then also another issue we have here is that if we go back to our docstring, or sorry, if we go back to the docstring, you can see that we wanted the output to be equal to menu underscore dict underscore one, which you can see is a string, and it gives us a tuple of two integers that's associated with. So going back to the solution, we wouldn't get that because we know that split returns strings. And so item price and item rating right now are both strings. So ignoring this if block for now, we know that this tuple is a tuple of strings. So what we are really returning is a string as the key. And instead of having a tuple of two integers of the value, we're just getting a tuple of two strings instead. So that's what the third point says right here. We're not getting the expected return type. So how do we solve these issues? We solve them as here. We can see, again, it's the exact same thing, just with a different name. We create a dictionary, and then we loop through the menu list as we did normally. And again, we call split as we did before. So everything, the logic here is the same, but this time for item price and item rating, because we want them to be integers, after we do the split call, we then convert it to an integer. So that's the first change right here. And now, instead of creating the tuple immediately, what we do is we then check if item rating is greater than the 5 or the threshold that we had. And if it is, we assign item rating to -1. This is allowed because right now we're working with integers and we're not working with tuples, right? So we want to modify all the values we could before creating any tuples. After we've done all our modifications, now we can go ahead and basically assign the item name to the tuple of integers or the two integers that we have, and we can create this tuple and then return it. So that solved all our issues that we had with our original solution, and this gives us exactly what we wanted. Moving on to the second practice problem, we have basically we're trying to duplicate elements twice. So we're given a list of numbers, so we want to return a new list where each element in the original list, which is list of numbers, is followed by a duplicate of itself. So let me just break it down. If we're given a list of 1, 2, and 3, we want to return a new list of 1, 1, 2, 2, 3, 3. Similarly, with 4 and 5, we want to return a new list with 4, 4, 5, 5. So basically just complete the doc string and the body of the function. And again, I'll give you guys like about like 5 minutes to do this. And yeah. Or do you guys need more time to solve this question? If you guys do, just like put it in chat again. Yeah. All right. I don't see anything in the chat saying people need more time, so I'll just go on to the solutions. So again, if we see we have some potential solutions, so let me just work through the logic with you guys. What we have here is that we're going through the basically the length of the list. We're going from 0 to n minus 1, and we're calling dot insert on the original list with the number that we're on currently, and we're just putting it at the current index plus 1. So we're going through every element, and the current element that we're on, we're basically just putting that value again at the element or the index right after it. So this does seem valid. This logic does seem like it solves exactly what the question asks for. However, this is not correct because we are modifying the given list instead of making a new one. Here you can see on the given list, we're calling dot insert. When if we were to go back to the question, we can see it says return a new list, right? So we know that this logic right here is not what the question is asking for. So how do we basically fix this? We can just create a new list. And there's many approaches to solve this question. However, the two that are listed here is if we can create a new list and again run through the parameter that we're or yeah, given the run through the argument that we're given, right? The list of numbers, the original list, and we'll just append each number twice into the new list. And skipping the comments for now, we'll just return that new list. So we'll just go into every original, or we'll go into the original list for every number, we'll just append it twice into the new list. The alternative solution is basically we can just call dot extend and give it a smaller list of the number that we're currently on, comma, again, the number we're currently on. So this creates a smaller list of the same number twice, and we can just call dot extend because we know dot extend basically is like it just extends our list using the argument that we give it. And we do that on the new list that we've created, and it'll return. And once we return that, it'll give us the exact same output. So again, there's multiple approaches. I saw some in chat, and some of them did look, or I'd have to work through them, but some of them did seem like they have potential. So yeah, there are multiple approaches, but these are just the two that we've listed out here. And yeah, so with that being done, our next section is files. So I'll hand it over to the next course rep.
Oh, okay. Just open the chat as well. Okay. So now let's talk about some files. So first let's talk about file operations. So first we have the open operation, which will take in two parameters, which is the file name and the mode. Uh, the mode can be one of the following: the string R, the string A, or the string W. The string R means read, and it is the default mode, which if you call open with. And this basically will open the file for reading, and you cannot actually change any of the content in the file. A, on the other hand, will allow you to change some of the content, but it will add it to the end of the file. And this will also create a new file if the file does not exist. And W allows you to write over any of the existing content in the file, and will also, like append, create a new file if the file does not exist. Um, and also note that the W mode will overwrite any existing data in the file. And one way we can call this is by calling just open and then final review.txt and using the mode A. So next, let's talk about some file methods. So we have read, read line, read lines, write, and close. So first, file.read. This is a method for reading a file. This will basically return the entire content of a file into as a string. Um, Secondly, we have file.readLine, which is a method for reading one line from the file. Uh, and by combining your knowledge of loops, we can make this so that we can read line by line from the file. File.readLines is now a method that will read all the lines from the file, unlike readline, and this will return it as a list of all the strings, where each string will be the line. And so in the list, we will have the first element be the first line, second element be the second line, and so on. And then we have file.write, which is a method for writing to a file. So for example, if we run file.write, good luck on the final exam, this will write a line into final review.txt as if we open it before using the W. Um, and now file.close. This is a method to close the file. This is always a good practice to close your file after you finished working on it so that we don't accidentally overwrite something in the file. So now let's go over example tracing readline and try to see what the output of this code will be. So first we have a text file which opens the text file.txt on so it will open this text file on the right, and we will open it using the mode R, which is just reading. So we will not be able to change any of the contents in this file. Next, we do a file text file dot readline. So basically, what this will do we will read the first line, and all this will do will return the first line. Next, we have a for loop. So now in this for loop, it's for line in text file. This line right here will read one line. So line will now have the contents of line 2 here, and then we will do another line which will read the line, and then we will read the next line 3. So basically what this does, we will be skipping line 2 because we will read the first line, and then we are automatically replacing line with the next line. And now we should check if the line is not empty. And since it's not empty, we will not break out of the for loop, and then we'll just print the line, and then we will strip all the elements. I think in chat I see does read lines return new line character? I believe it does return new line characters. And yeah, here we will print the new line, and then we'll get line 3. And now we'll just go over this loop. So as before, we will read the line. So we'll go to line 4, and then we'll go to line 5, because we will do another read line, and then check if it is not empty, and then we'll print line 5, and then strip it from all new line characters and spaces in front. And then we'll do it one last time. Now we will check if line is in the text file. So we get the next line, and then we get another line by the next read line function. Check if it's empty again, and then we will print line 7. And then we will go back to the top. However, since there's no more lines to be read, this will automatically just go to the end, and then now we will close the file. So now the output will be just line 3, line 5, and line 7, skipping the lines 1, 2, 4, and 6. So now let's go to a practice with read files. I will give you 5 minutes to try this question. And so basically, what we need to do here, we will be given a file like this. So in the file, we will have the last name, first name, uTOR ID, and then their student number. And then that will be stored in every line. And basically, what we need to do is go through each line, and we have to store it. We have to create a dictionary that maps an ID to the content of the file in the format of their uTOR ID, student number, last name, and then their first name, all in a list. So, for example, for this, for the example provided above, we will need to produce an ID one and then store um, the content in the utor ID, student number, last name, and the first name, and then ID two, and then the same thing, same list here. Yeah, and as I said before, I'll give you around 5 minutes to work on this. I think 5 minutes has been up. If anyone needs more time, just type in the chat. Okay, yeah, I will give you 3 more minutes. Okay, so since it is 8 right now, um, and how many of you guys still need more time? Because if so, we could take a 10-minute break now, try solving the question a little, give you guys more time to solve the question as well, and take a break, and then we can come back and look at the solution. Okay, it seems like we got a few solutions. Um, so I guess we could go over the solution first and then take a break. Um, So here, this is the solution for the get students function. So as I said before, we need to create a dictionary that maps the student IDs to a list of utor ID, student number, last name, and first names. And student IDs are assigned sequentially starting from one. So we will start from one and then increase as we go. So here, so first we will set a base student ID to be one, and then we can keep track of that as we go through the for loop. And then we will create an empty dictionary to store all our information. So now we will go through all the lines in the data file we are given. So for a line in data file will return. So every line will be stored in line if as we go through data line. So basic, and then so the first line we will look at uh the first line, and then we will do a strip which will remove all spaces and new line characters from the front and the end, and then we will split all the strings but with a comma. Effectively, um, this will give us this will just split every string into a list. So then now we just take student data, and then we take the second element, and then we combine the second element, um, and then we go to uh, so essentially what this is doing is putting the first two elements into the back, which as you can see, so we take the name and then we just add them to the end. So then that we will have the utor ID and then the student number, and then we will have last name and then first name. And then we will just store that into the student ID um, key of the dictionary, and then we will increase the student ID by one. And then we will go through this list, and then line will go to the next line, and then we will do the same process, and then until we reach the end of the file. And at the end of the file, we will return the dictionary. Can we use while not equal to um yes, we you could use that. However, I believe you should read line. If you're going to do that, you should do line is equal to read line inside the while loop to make an exit condition. Yeah. Um, we have to change the name. I don't think we have to change the name into the lowercase format. I think just the format inside the string, the file is fine. Yeah. Yeah, so I guess I will give you guys a 10-minute break before we go into test cases. And yeah, I guess I'll see you guys again at 8:15. Um, okay, let's get started again since it is 8:15. I think I saw a few questions in the chat about this question here. Um, I think people were a little bit confused on the for loop. So essentially, the reason we're skipping the second line and the second, the fourth, and the sixth line here is because when we run this for loop, so for line in text file, so this line right here, as when we enter the for loop, this line right here will store the first line that it will read. So since we read a line here, since we read so we did text file dot read line, this will already have read the first line. So um so then now we will read the second line in using this for loop. So the for line in text file will read the line two. And so line will now contain the string of line two. However, since we do line dot text file dot read line right after, that will essentially read the next line, line three, which now line will be line three. So essentially in the for loop, we are reading line two, and then we will be reading line three. So when we print, we are storing line three, and then line two is now lost. And this is basically will continue with all the others. So we will read line four, and then we will read line five right after. So then line four will be not skipped. And then same thing with line six. Um, so yeah, if anyone has any more questions, just please type them in chat. Um, and yeah, let's go on to generating test cases. So for generating test cases, we need to first figure out what we're testing. So are we testing with or without mutation? This is especially important for lists because we need to make sure that we are returning a new list, or if we are if we are changing the original list. And then now there are a few rules that we should follow for a good set of test cases. So first, we need to always make sure that we are testing with valid inputs. So in the doc string, we will have preconditions, and we need to make sure that our test cases are following those preconditions. Secondly, we need to try to think of edge cases. For example, in like a minimum function, we can try to think of like, uh, what if we have negative? What if we have positive? And what if we have zero? So something like that. And then we can think of some normal cases, some cases that we could always just put in whenever we run our code. The first case is, and then we need to make sure we create a test case for each category. And as we create test cases for each category, try not to make redundant cases, as another case will have already covered that case. For collection types, like lists and tuples, we can always test zero elements, one element, and many elements. That is one one of the test cases that you can always do, and try to include all possible branches. So what that means is try to cover test cases so that every if statement will be covered. And then for number value test, we can always test them with positive and negative values. So here are some things that we can do for strings and integer testing. So for strings, we can always test the empty string. We can always check if it is case sensitive. And if it is case sensitive, we can always do like first letter is uppercase, and then we can do like some letter in between is uppercase. And then we can always test white spaces. So what happens if we have a lot of white spaces in the front or the back or both? And then as well as punctuation. Since punctuation is part of valid strings, we can always incorporate those to create new test cases. On the other side, we can always do integer testing. For integer testing, we can always look at positive values. We can also look at negative values. We can look at zero, and we can always do a mix of positive and negative values if it is a list. So, um, what is unit testing? So unit testing is a test to test a single unit of code. For this course, we are defining a unit as a function. So how do we define a test method? So first, we will always use the prefix test underscore, and then we will follow that by a brief description of the test case as the name of your test. And then to test your function, we can always use the following three built-in methods, which is assert equals, assert true, assert false, and there are many more in documentation. And by using those, this is basically what will do the checking if the description is correct. So, so now let's look at the assert equals, assert true, and assert false. So assert equal will take in two objects and a string, and basically it will compare the two objects. And if the two objects are equal to each other, then it will print then it will just continue. However, if the objects are not equal to each other, then the final string that we provided will be printed up. Similarly for assert true, if the Boolean is not true, so if it is false, then we will print out the message that is provided here. And then in the opposite case, assert false, basically if the Boolean here is not true, if the Boolean here is not false, so if it is true, the string will be printed because the Boolean value is true. And for those who are wondering about the self dot, basically the self dot is there because the test cases will be defined in a class, and to call the methods, we need to use a self dot function. Um, here, so now we have example of a unit test. So let's go over this. So basically, here, let's take a look at the function first. So the function we are testing is a number of boxes, and it will take in a parameter, which is the number of pencils, and then a second parameter, which is the pencils per box. So now let's take a look at the description. So basically, this function will return the minimum number of boxes needed to pack the number of pencils if each box can hold up to pencils number of pencils. So basically, the first parameter is the total number of pencils, and then the second parameter is the number of pencils we need to put in each box, and then we'll return how many boxes we need to fit all the pencils in. So we have a few test cases here, and then we can just see that we will return the ceiling of the number of pencils divided by the number of pencils per box. So now we can think of a test case. So one example test case we can think of here is test the number of boxes if we have all full boxes. So will be that test case. So as you can see, we have the test underscore as the prefix, and then we provide a short description based on what the test case is doing. As I mentioned before, since we have full boxes, the number of boxes are all full. This will be the test description here. So first we will store what the function returns, to actual, and we will pass in the parameters of 200 and 10 because 200 pencils will fit evenly into 20 boxes if we provide 10 pencils per box. So that is why the expected is 20 because we have 20 boxes if we put 10 pencils per box for 200 pencils. And then we will write a message that will basically just say, when we call this function, we expected the expected, which will be 20, but then we actually got the actual value that the function returned. And this will only be printed if actual and expected are not equal to each other. So here in assert equal, we will pass in actual and expected, and the message. And as I said earlier, the message will be printed if these two are not equal. So now let's try an example. Let's try to think of some test cases. So we have the function called get number of uh, mins, and this will essentially return the number of smallest elements in the list. So here we have a few hints that we could provide to try to look at this. And I think I will give you guys 5 minutes to try to come up with test cases and make sure that these are, we try to think of a test case for each category and that you guys do not have redundant test cases. I think it's been around 5 minutes. So do we also test for empty list? Oh yeah, we should always test for empty list if there is no precondition stating that the list is not empty. So yeah, let's go over it. I think we have a few solutions. So yeah. So the test cases we could always provide are an empty list. So we empty list with no elements, and then the expected result will be 0 because we are getting the number of minimum elements. So since there's no minimum elements, we're just getting 0. On the other hand, we have one element in the list. Since it is the only element in the list, it must be the minimum. So our expected result will be 1. And then we have a longer list with one minimum element. We can see that -3 is the minimum element and it is only repeated once. So we will, the expected output will be 1. And then now we have a longer list with more than one minimum element, which we could see that 0 appears 3 times in the list, which we will return 3. And then we have a case with a longer list with all minimum elements. And then we can see that 5 is repeated 3 times. So then our expected result is 3. This is another question that we have. Since we already went over one before, I'll just go over this quickly. So basically for this one, we have a replace function. What we will do is we will replace every occurrence of x with y in the list. So any occurrence of the first parameter will be replaced by the second parameter. So here we can think of the empty list again, where we pass in 1 and the letter A. Since the list is empty, there's nothing inside. Our expected result is the empty list. Also, we have one element list with no x in the list. So if there's no x in the list and we have one element, this will mean that basically nothing is being changed. So our expected result is just the list itself. Next, we have one element list with x being in the list. So that means we must change the 1 into the y, which is the expected result, just a list containing the string a. And now we have one long list with one x. So in this list, we can see that we have 1 appearing in the first element and nowhere else. So we have one occurrence of x. So then now we can replace that with y, which is the string a, and then we will get A005. And the next case is a long list with multiple x's. So we can see that one appears multiple times in the list, and we will replace every case with the letter A, and then we will get this expected string. And finally, we have a long list with no x's. Since there is no x in the list, we will not be replacing any of the elements with y. So then this is why we will just get the list that we pass through into as the expected results. So some of you may be wondering what the difference between doc test and unit test are. So what doc tests are is basically they're used to provide examples of what the function should output, and they basically will support the doc string by giving valid inputs and expected outputs. On the other side, unit testing is used to test the actual functionality of the code, and this will ensure that the function is correct and works as intended under various conditions. So doc tests are basically just to strengthen the doc string, and unit tests are actually used to test the code and see if it works under all conditions. And now we get to sorting. I will pass it off to the next course rep for sorting.
Give me 1 second. I'm just gonna share my screen. Can you guys see my screen?
Yep.
Okay, good. All right, awesome. Okay, so now we're on sorting, and there are so many sorting algorithms that exist, and we're just focusing on selection sort and insertion sort, which is what you have learned. So with insertion sort, the main idea is that you're going through each element of the list, and the current element that you're on, you're going to compare it to whatever elements are on the left side. And if you need to make some sort of change, you just swap it. So for this example, we're trying to sort this list in a non-decreasing order, and you'll see what I mean as we go through this example. Okay, so here's the code on the bottom right corner, and we're just going to go through this example. So we're at the first element of the array, and I'm currently trying to look at whatever's elements to the left of it, right? But notice how there's nothing to the left of it, so we're just going to leave it. Okay, then we go to the next element. Now we're at the next element, 8, and I'm going to, again, compare to whatever is on the left side of it. So we're comparing it with 5. And since we want this list to be in a non-decreasing order, so that means it's going to increase as we go through the end of the list. There's no need to move it. It can just stay as it is. So we just move on. Okay, we're at the third element of the list. Again, we're comparing to whatever is on the left side of it. So we see that 10 is greater than 8. We don't need to move it. We're good. Okay. We're on the fourth element of the list, 2. And this time, again, we're comparing it to whatever's on the left of it. So we compare it with 10. And notice how 2 is less than 10. So we definitely need to swap because we want this list to be in a non-decreasing order. So we're going to swap. Okay, now we have to compare it to 8, right? We're always comparing it to whatever elements are on the left. And we see that 2 is less than 8, so we need to swap. Okay. Finally, we have to compare it with 5. 2 is less than 5. We swap. Okay. All right, so now we're on the fifth element of the list. And again, we have to compare it with whatever's on the left. And we see that 4 is less than 10, so we switch it. Then we look at 8. 4 is less than 8, so we got to switch it. 4 is less than 5, switch. Okay. Again, we're at the second last element of the list. We compare it to whatever's on the left side of it. 1 is less than 10, we switch. 1 is less than 8, switch. 1 is less than 5, switch, switch, switch. Okay, we're finally on the last element of the list, and we see that 8 is less than 10, so we switch. And notice how we have 2 elements that are the same, so we can just keep it as it is. And we're good, it's all sorted. Okay, so now we're going to move on to selection sort. And this is a little different from insertion sort because this time, so whenever you have the current element, you have to traverse the rest of the array. You either find the smallest or largest value. It depends on what you want. And you just swap it with the current position and you just keep repeating. So in our case, in our case, we want this list to again be sorted in a non-decreasing order. So we're going to start at the first element of the list. We're going to find the minimum, which is 2, and we just swap. Okay, so then we go to the second element of the list. We find the minimum, and we swap. We're at the third element of the list. We find the minimum, which is just 8, and we swap. And notice how we're done because we reached the last element of the list. There's nothing more to find the minimum or the maximum. We're good. Okay. And now we move on to runtime. So runtime deals with how do we measure the efficiency of our programs. So we do this by counting the number of operations or steps that it performs relative to the size of our inputs. So what are these operations or steps? It really depends on the context. So it could be maybe the number of comparisons or the arithmetic operations. And don't worry, it'll always be specified for you. For example, it could be maybe you have to take into consideration the number of iterations for the loop or how many comparisons does this code perform. the inputs could be, lists, strings, etc. The size, it could be, the length of a string, lists, etc. Okay, so we have to consider the following function. So, in the chat, if you want, you can provide me an example of an input list of length 5, at which results in us to have to keep iterating through this list the most times, like the maximum amount of times we can do for the function contains. I'll give it a minute. Okay, so an example we could do. Oh, yeah, that's a good one. Yeah, it was really similar to the example we have. That's pretty good. Yeah. Um, okay. So, sorry, 1 second. It's okay. Is it? Yeah, okay, we're good. I don't know what happened. It just glitched. Okay. So, similar to the example in the chat, yeah, you could do that. And so what makes it run the most times, like the most iterations, is you would want to have an array, and since we want it to be length 5, you need it to have like the second argument needs to either be the last element of the list or it's just not there at all, right? So if we try to run whether it be the example in the chat or our example with this code, we can see that we have to keep iterating until we've reached the last element. And it's either it's there or it's not there. So basically, the most iterations for this loop, it's what's the length of the list? So since our length is 5, we're gonna have 5 iterations. Okay. Okay, this time it's gonna be the least amount of iterations for the loop. I'll give it like 30 seconds, 1 minute. Okay, that was really quick. Yeah, that was literally the example we have right here. It can't be an empty list. Like I know what you're thinking. I was thinking that at first too, because we specified a list of like 5, but if we didn't, yeah, an empty list would be good. Yeah. Um, don't worry about it. Yeah. So, yeah, so for least iterations, you basically want your second argument to be the first element of the list, right? Because when you try to run through this loop, you're going to run it once because when you compare the first element of the list with the second argument, they're equal, right? So you're just going to return true. We only did one iteration of the loop. So that's awesome. All right. Okay. So this time we're taking into consideration the number of comparisons. So for the worst or best case, really, it's going to depend on the most or least number of comparisons. Okay. So, so this time, same thing. You're just going to give an example of list 1 and list 2 of both are length 5 that will result in the best case. And remember, we're taking into consideration the number of comparisons. So I want to compare the least amount of times. I want to do less work. I'll give it like 30 seconds. Okay. So when you're considering the best case, for running same elements, right? Like I said, you want to do the least amount of work, so the least amount of comparisons. So in our example, as you can see, we have a list, 1, 2, 3, 4, 5. And notice how the first element is not in the second list, right? Yeah. So when we try to run this code with list 1 and list 2 over here, what you want to do is, right, so we're comparing it. We're going to take the first element in list 1 and we're going to run the contains function, right? So over here, when we compare each element to list the first element 1, right? They're not going to be the same. So we go so yeah, 1 does not equal 0, it does not equal 2, 3, 4, 5, right? So we're going to return false. Why? Because element 1 is not in list 2. Yeah. Okay. So this is just explaining it, like, right? We want to make sure that the first element in list 1 is not in list 2 at all. That way we can get the best case running. And like I said, it's going to do 5 comparisons, which is also known as, the length of both the lists. So why can't we consider the earliest that contains can return every time? Because when the item is not an element of lists, right, contains will do 5 comparisons, which is what we saw in this example. And if item was the first element of lists, right, contains will do 1 comparison. It would just find it over here and be like, yeah, I found it. If it was the second element of the list, so 1 was here, it would do 2 comparisons. If it was the third element, right, 3 comparisons, and so on. So you can see that we're calling contains so many times, we're comparing it so many times, we're going to have so much more comparisons than 5 comparisons. And, like we said, we want the best case, so the least amount of comparisons. Okay, so in general, if we are given 2 lists of length n, then in the best case, how many comparisons will be performed? Right? So like we said, an established best case occurs when the first element of list 1 is not in list 2. So if we consider these 2 lists, they're both length n, right? x1, x2, xn. And notice how x1 does not appear in list 2, right? Because we want the best case. Instead, we just have some y, as you can see. And if we count the comparisons we're doing with this code, right? We're gonna see if x1 is in the list, right? We check at y, no. So that's 1 comparison. We check at x2, no. We've done 2 comparisons, and so on to the point where we've done n minus 1 comparisons and then n comparisons. So counting the comparisons in total, we've done n comparisons. So it is linear. It's very similar to that example where the length was 5. If you still don't get it, I suggest you try running the code with both lengths n, and you can see that you will end up with linear. Okay. Okay, this time we're gonna have 2 lists, both length 5, and we just want a result in which we call contains 3 times in total. So there's so many examples you could do. The example we came up with is where you have 2 lists, and list 1 is 1, 2, 3, 4, 5. And notice how the element 3 is not in the list. Why? Because, well, if we try to run this example with the code, we're going to see that we have call contains 3 times. So if we start with the first element 1, we call contains with it, right? That's 1 call we've done. Okay. We call contains with the second element. We can see that it is in list 2, right? So that's 2 calls we've done. And when we go to the third element, 3, and we check to see whether 3 is in list 2 by calling contains, that's 3 calls we've done to contains, And notice how it's not even in list 2, right? So this function returns false, right? And we get to return false because the condition is true. Okay. All right. So now we have to again give two lists, both length 5, that will result in the worst case to run. So again, we're still counting the number of comparisons, but we want so many comparisons done. We don't want the least amount. So an example that could work is this, where the first list is 1, 2, 3, 4, 5. And notice how the last element is not even in the list, the second list. So why is it that it is the worst case, like an example? Well, because when you start with element 1 in list 1, and you're calling contains to check whether list 2 has it, notice how many times you're comparing it. You're comparing it like 5 times because 1 is all the way at the end of list 2. So that's like a lot of comparisons you're doing. And then when you do it for element 2 and you check to see whether 2 is in list 2, right? Again, you're comparing it so many times that it's all the way at the end of the list. And same thing with 3. You're going to check again, right? It's a lot of comparisons you're doing. 4 and 5. Notice how 5 is not even in the list, so you got to go all over it again. So it's a lot of comparisons you're doing, which is why it's the worst case. All right, so in general, if we are given lists of length n, then in the worst case, how many comparisons will be performed? Well, like we said, the worst case occurs, we saw with that example, when the first n-1 elements of list 1 are in the last n-1 positions of list 2, and the last element of list 1 is not even in list 2, like we saw in that previous example. So these are my 2 lists, right? I got x1, x2, all the way to xn, so n elements. And we saw that x1 is all the way at the end, x2 is all the way at the end, xn-1, right, as we continue, will be here. And we see that xn is not even in the list, which is what we want for the worst case. So if we count the comparisons we're going to do, it's going to be this huge sum. So let's just go over it. So when we start at x1, like for each element in list 1, so we start at x1, we call contains to check whether x1 is in list 2, right? We're going to compare it x1 to the n elements, right? So we're going to compare it to 1. Y. We're going to compare it to xn-1 and so on all the way up to x1. And that's n comparisons we've done, which is why we have an n over here. Okay? And then if we go to the second element of list 1, x2, this time we're going to compare it again to see whether x2 is in list 2, right? So we're going to do a comparison here, another comparison here, and so on all the way up to x2, which we found. But this time we've done n-1 comparisons, right? Because we didn't go to x1. We found it over here. So n-1 would be somewhere here. And we keep going, right? And it keeps decreasing and decreasing. And then over here, when we reach xn-1, right, we're going to just do 2 comparisons. We compare it with y, we compare it with xn-1, and hey, look, we found it. So it's going to be 2. Then we've reached the final element, xn. So we have to check whether xn is in list 2. And notice how, as I'm comparing it, xn does not even appear. So I have done n comparisons again. So which is why we have 2 n's over here. And we have all of this. And we can simply represent it as like the summation formula from 2 to n, right? So it would be 2 plus 3 plus 4, da 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 da, all the way up to n plus n. Is this okay? I think it is. Okay. All right, so this is what we had so far. And we can represent this summation, this big summation, to 2 tiny parts. You could write it out and you can see that they both equal the summation, like from 2 to n, it does equal the summation from 1 to n minus 1, because the ones will cancel out and you will still have your 2 plus 3 plus 4, all the way up to plus n, and of course your second n over here. So now, is it linear, quadratic, cubic, etc.? I mean, we know this part is linear. So now we have to focus on this part, this big summation. Okay. Notice how I could literally pair n and 1 together, right? So that's n plus 1. And then look here, I could literally pair n minus 1 and 2, right? Because that gives me n plus 1. And then the same thing here, I could pair n minus 2 and 3 together, and that gives me n plus 1. And if I keep on doing this, I'm going to have n over 2 pairs of n plus 1. So my summation, this whole thing, is going to equal n times n plus 1 over 2. And we have a quadratic number of steps. Why? Because if I distribute this n to the n and to the 1, right, we get n squared, and that's quadratic. So we have a quadratic number of steps. So it is quadratic. All right, so good luck on the final. You guys got this. Don't worry. Good luck on your other finals as well. Have a great night.
Hey, thank you. That wraps up the review seminar for AO8. If you have any follow-up questions, please use the AMACSS community Discord. The recordings will be uploaded there once the link will be shared there once the uploaded is shared to YouTube. Then we'll also share the slides there. Have a good night and thank you for coming.